Welcome to deploying high performance driver monitoring systems presentation. I'm Mark Hoops. I'm Director of Industrial and Automotive, and I've been at Lattice for a little bit over 4 years. First, I'd like to cover some of the major automotive infotainment trends, especially trends around AI inside the cabin. So first of all, one of the key applications is something called attention tracking or driver monitoring, which is the main topic that we're covering here today. But other ones where they're adding new features to the vehicle are things like voice control or gesture control, and also smart maintenance and other types of AI-related activities where they can gather more information about the car and hopefully keep you from getting stuck on the road and things like that. In addition, there are things like electric mirrors and other types of sensors being deployed internally. But overall, the cabin is trying to get smarter and more convenient, so it's easier for you to interact with the car and not be distracted and be safer overall. For driver monitoring systems, there are actually some very alarming accidents in terms of statistics that are caused by distracted driving, basically. And that's, the guy in the upper corner here is about as bad as you can get with a drink in one hand and food and a cell phone and everything. And I think cell phone is the number one distracted driving type of incident. But basically, almost 80% of accidents in the USA are caused by distracted driving and 65% of near driver accidents. So it's a big, huge problem. And so goal is to try to make cars safer so that the car can monitor you and alert you or help to prevent sort of accidents overall. And there are regulations actually coming into play that will mandate essentially driver monitoring systems to become part of a vehicle, similarly to the way most cars these days have backup cameras, also required by law. And Euro NCAP is one of the standards bodies. NTSB is another one. And there are a couple of different types of monitoring systems. If you've got a fairly recent car with a cruise control, you might know of a feature where you have to be paying attention by holding on the steering wheel and actively steering. That's something called inferred driver monitoring. And there, by sensing pressure on the steering wheel, they can understand if you're paying attention and at least monitoring the wheel and correcting for drifting left or right. But that's only so good, right? You could have your hand on there and not really be looking or paying attention at all. The best thing is a camera-based monitoring system. And you can see in the lower right-hand side that, starting in 2021, 2022, the camera-based systems are going to start to take off, and they will eventually essentially take over because you can get a much better indicator of what's going on in the car with the camera monitoring systems, and they'll probably end up being essentially required in every vehicle in the future. So if you take a look at some of the different things that driver monitoring covers, the biggest thing is understanding how distracted are you? Are you distracted at all? And if so, how much? So are you sort of staring straight ahead and not moving and don't seem to be responding to anything on the road? That could be a long distraction time. Or short distraction time, maybe you're looking at the infotainment screen or looking in your side view mirrors. That's really part of normal driving. But if you stay there a little too long, then it'll count it. Other things are phone usage. That's like we said before, one of the biggest problems that people face today. Another thing, a lot of us may not get enough sleep. We're on a long trip, so if you're drowsy, they can detect, you're blinking too much, or your eye closure, or your head is starting to nod off a little bit. So what is your fatigue level? And then the worst case of all is if somebody passes out, maybe they have a health condition or something like that. So The monitoring systems are meant to catch all these different types of things and prevent accidents, and also alert the driver by shaking the wheel or vibrating something to basically try to get the driver's attention. Audible sounds as well. If you look at the timeline from Euro NCAP, you can see there are, first of all, many different things in the roadmap for safety features that they want to add to vehicles. And if you look from left to right, there's sort of a starting phase, and then they have the protocol release, and then they have the implementation. So they've got different types of crash protection, different types of features and functions on the vehicle. On the roadmap 2025 safety rating, you can see driver monitoring, where it got started in kind of 2018 time range, but when it's going to be essentially mandated is by 2024. So after 2024, you must have driver monitoring implemented in a vehicle in order to sell into Europe. And then you can see here also many other safety features that are being incorporated. So it's going from being sort of a luxury feature in higher end cars to being mandated in the future. And another way they have of convincing people to adopt cars with advanced features is what's called safety ratings. So most people are very interested in having a high safety rating on their vehicle. It's one of the key things that they pay attention to, besides, do you like the car or not? So if you don't have excellent performance and crash protection and a vehicle that's very well equipped with comprehensive crash avoidance technology, you will not be able to get a 5-star safety rating. So previously, safety ratings have all been about crash tests, right? How well does the passenger and driver survive a crash test? But it's going beyond crash testing to including also crash avoidance types of technology. And then if you have pretty good performance and crash protection all around, but not that much crash avoidance, you'll get like 4 stars. So no longer will you be able to get a perfect rating, even if you have really good crash protection. And it gets worse and worse depending on the amount of features and functions that you have available in there. So this is a very strong incentive for manufacturers to include more and more safety features, because they want to be able to compete with others and attract consumers that are interested in safety. And if you look at vehicle monitoring, there's the interior part of the vehicle where you do monitoring for things like I mentioned already, attentiveness and drowsiness. You could also use driver monitoring to understand who is driving the vehicle, and you could set up all of the preferences for that user or that driver, like their seat position, mirror position, radio stations, temperature levels, things like that. So it's nice to be able to recognize who's in the cabin, and then also to understand. Another nice thing is to understand emotions or moods. If somebody's upset, maybe they won't be quite as safe at driving. In addition to monitoring the driver, they also want to monitor other occupants in the cabin. For example, they'd like to know if a child is present or not, or somebody in a child seat. You have different things you would turn on and off in a vehicle in order to make it safer. Understanding body movement, and even being able to detect and measure vital signs. If you can detect if somebody's having issues with heart rate or something like that, you can understand maybe if there's an emergency system coming up, and you can help mitigate and avoid crashes. Obviously, the cabin monitoring, are your hands on the wheel? Do you have your seatbelt on? Are there objects in the seat or not? Another one is things like monitoring the interior of the vehicle. Say you leave the vehicle, are you leaving pets or maybe small kids in the car? That could be dangerous on a hot day or something like that. So all kinds of safety features and functions. They normally use cameras, but they also add sometimes radar, and also use thermal cameras. And that's very good at identifying warm bodies, which would be humans or animals, as an example. So lots of different technologies available. And there's a big focus on monitoring not only internal to the vehicle, but also exterior to the vehicle. See if somebody crashes into your car while it's parked, or somebody's attempting to break in, things like that. So it's a major trend in the industry. And one of the tricky things about in-cabin monitoring is you're in a vehicle and you have all kinds of different situations where you can have bright sunlight shining into the person or into the cameras. The driver could have sunglasses on or other types of things that can obstruct their eyes, so you can't tell really if they're paying attention if you couldn't see their eyes. Also nighttime situations where it's dark, so very low light. So a lot of different kind of situations in terms of challenging lighting conditions. And for that reason, normally they will use something called an infrared camera. And you have an IR lighting system that floods the light so that you can see in any type of lighting conditions and also see through sunglasses. And then the camera is an infrared sensitive sensor that allows you to see in all those lighting conditions. That makes it so it's much more reliable to be able to track not only the driver's motions, but also to be able to look at their eyes and see where they're actually gazing. And you can have different levels of interior monitoring, sort of the bare minimum required by law, and then additional features and functions that you could add with more and more capabilities. So most manufacturers will want to have a scalable system that can offer more and more capabilities for higher level vehicles. And if you look at the overall system trends, many of the solutions are running on dedicated hardware. Some of them are effectively software only, which means it's an application that runs on a shared ECU, which is normally going to be the infotainment or cockpit domain controller. So that thing runs your central screens and things like that, and also would have a camera feeding into it and have the algorithms running on the CPU. Also, another major trend is enabling beyond just driver monitoring to multi-seat occupant detection systems for high-end luxury vehicles, and also for any kind of robo-taxi or vehicles where you have passengers that you want to monitor as well. The main technology is 2D mono cameras, and as I mentioned before, they use near-infrared LEDs to illuminate the object or person and be able to see what's going on in all the different lighting conditions. There are some folks that are using time-of-flight sensors or radar or LiDAR, but those are a bit more of a niche application. And although driver monitoring is far and above the primary application, there are other types of additional information that they try to get, like understanding who the driver is, understanding the motion or state of health as well. I'd like to switch into what is Lattice doing to enable driver monitoring systems. So a few years ago, we acquired a computer vision AI company called Mirametrix. It's now a wholly owned subsidiary of Lattice. And they've got technology they've developed over many, many years to understand human presence and human intent. So they can detect people or objects. They can actually sense how far away you are from the camera. They can do 3D head pose and gesture tracking, recognize faces and identify people and landmarks. They can track where you're looking with your eyes, even behind sunglasses. They can also see if you're leaning off to the side, or what your pose or skeleton sort of directions in, and then detect many different types of objects. For example, if you're holding a phone in your hand or something like that. And Mirametrix has developed over this past 10 years something they call the Mirametrix Attention Sensing Engine, or MACE. And there are many, many different modules that are included in the system. Some of the kind of highlights of the features are that it is sensor agnostic. You have a lot of different choices in terms of what types of sensors are used. It is also hardware agnostic or platform agnostic. You can run software on various different platforms. You can run things in FPGAs or not. It is highly optimized for very high accuracy and low computational footprint. Edge AI algorithms are very difficult to implement, and it takes a special skill, especially to be able to implement accurate algorithms and implement them in a low computing footprint at low power. And also, of course, you need to have low latency. All the compute power needs to be on board in the car. You can't send things up in the cloud. The latency is way too long and you wouldn't be able to react fast enough. So those are the main features and functions. And they have, as I mentioned, a large capability to detect various different objects. Obviously identify the face and face landmarks. They have what's called a fatigue module where they can count how much you're blinking or how long your eyes have been closed, and gather fatigue information and statistics. They can also determine your gaze, the point of gaze, and the region of interest. So what angles you're looking at, to see if you're looking at, paying attention to where you should be or not. Can understand things like gender, or do you have classes on, or some sort of emotions or protections. Identify users. They can also provide things like background segmentation, which is used commonly in things like conferencing, where you want to have different backgrounds for video communications. And also they offer things like image enhancements to improve the video quality overall. So wide range of different types of capabilities in the whole suite of computer vision and AI algorithms that are offered. And we offer these to end customers so they can take this SDK and all these tools and implement their own end solutions if they'd like, or we can have our team of AI and computer vision experts work with you and to develop them for you. So if you look at the fit overall for the Mace engine, why is it particularly suitable for automotive? The top reason is that it's focused on using vision and getting the best out of it to get the best understanding of what's going on in the vehicle, not only for the driver, but also occupants and objects and things like that. So it's the best source for intelligence and information for monitoring. We have a large team of AI and computer vision talent and expertise that can assist in customizing and providing differentiating solutions for end customers. And it's a market-proven platform, commercially deployed, and widely commercially deployed in various different markets for many years. So some of the benefits are the tracking performance is state-of-the-art. Reliability is very high, and accuracy. You can differentiate your products from others. There's innovation enablement, very low system level performance requirements and power requirements, and commensurate. The cheaper your processor is, the lower cost it's going to be. You don't need the super high performance. And the last but not least, a flexible module. So we can run on any CPU. It could be ARM, it could be x86. It can run on GPUs. We can run in hardware on FPGAs, or we can do hybrid processing between the FPGA and the SoC, where we do some initial processing, some low latency things continuously in the FPGA, and then we wake up a CPU to do some more sophisticated processing as needed. And just wanted to show you now a little bit about the benefits of running an FPGA in terms of power, and performance. So performance and efficiency. You can see here a Crosslink NX implementing a driver monitoring solution, and it's up to 20 times better performance than ASICs that have been targeted for this types of applications. And then on efficiency, we get up to 7x the performance of various different ASICs. So a lot of folks think that an FPGA can't be optimized for these types of applications, but it just turns out that our low power devices with the right mix of on-chip memory that local processing in the device can make for a very compelling solution that has good performance and good efficiency. So that covers the overall introduction to driver monitoring. Now it's time to take a couple of questions. So the first question is, what different types of solutions can Lattice's driver monitoring system be deployed on? Well, I touched on that earlier. So we're an FPGA company, so naturally FPGAs are our primary target. But we also enable flexibility to be able to offer solutions on any types of processing unit. One of the most common ones in vehicles is ARM CPUs, so that's a major target. Also, GPUs or NPUs that are optimized for AI can be used as well. And then, what are the advantages of FPGAs in driver monitoring? Well, we have a lot of flexibility to be able to choose different types of cameras and sensors and the communications between the camera and the rest of the subsystem. We can offload and pre-process some of the AI inside that camera, inside the FPGA. So it'd be lower power and lower latency. And then we can do hybrid processing between the FPGA and CPU or something like that. Another use case is for external vehicle monitoring. If you're parked and you want to have something called Sentry mode, where you take off for the day, your car is parked, and you want to have cameras monitoring it the whole time. If you're running that on a high-performance CPU or something, your battery will be drained. Even if it's an electric car, it'll reduce your range, so you don't want to do that. In an FPGA, you can take and run milliwatts worth of power dissipation for all of the different processing. So it allows you to extend battery life and keep monitoring on for the whole time. Last question, have we gotten customers with the solution? And the answer is, yeah, we can't say who, but we do have a European OEM who is deploying this solution. And that's all I have for today. So thank you, and please reach out to me if you have any other questions later.